Imagine a wonderful bank that pays 100% interest. You have $1. Then after 1 year, what's the maximum you could turn $1 into? When you put this $1 into this wonderful bank, the bank will pay you the interest different times a year. We call number of times the bank pay you the interest compounding period, compounding annually, which means they will pay you the interest only once in a year. Very beginning, you have $1. Then at the end of the year, you will earn interest. That is 100%. Altogether, you will get $2. Compounding semi-annually, you will earn interest twice in a year. So the first half a year, they will pay you 50% of interest. The second half of the year, they will pay you another 50% of the interest. In the first half of a year, you get this $1, then you get the interest. All this money will be reinvested for the second half of the year. So the total money you will earn, you have to multiply by 1 plus 50%. Then I can write down $1 times 1 plus 50% square. That equals $2.25. Compounding quarterly, the interest will be calculated 4 times in a year. Each quarter will earn 25% of the interest. All the interest will be reinvested. So we have 1 times 1 plus 25%. Then times 1 plus 25%. 1 plus 25% for the third quarter. Then times 1 plus 25% for the fourth quarter. 1 times 1 plus 25% to the fourth power. Put into calculator, you will get $2.44. Before we go to compounding monthly, let's change the percentage into fraction. For this 50%, basically I can write down 1 times 1 plus 1 over 2 square. Here I can write down 1 times 1 plus 1 over 4 to the fourth power. For compounding monthly, the interest will be paid 12 times a year. Each time it will be 1 over 12 of the interest. That is 1 over 12. So the interest will be calculated 12 times. According to this pattern, we can get the money after a year 1 times 1 plus 1 over 12 to the 12th power. That equals $2.61. Then compounding daily, the interest will be calculated daily. And each time, the interest will be paid 1 over 365 of the interest. The interest will be calculated daily, which means 1 times 1 plus 1 over 365 to the 365th power. That equals $2.71. What if we calculate the interest every single second. We will get 1 times 1 plus 1 over 365 times 3600. Then to the 365 times 3600 equals $2.72. In other words, this is the maximum dollar you can get from the bank. This value basically is E. When the limit as n approaches infinity of 1 plus 1 over n to the nth power, this value will be E. Do the second divide, enter. This is E. This time, let's calculate. You still have $1 and our percent interest compounding n times in a year. How much you will turn $1 into? So in a year, compounding n times, it will be r percent divided by n. Basically means r over 100 times this n. After the first period, you will earn 1 times 1 plus r over 100 times n. Then it will be compounded n times, so to the nth power. This will be the money you will get from a bank. You still have $1 and our percent interest compounding n times in t years. If we still have $1 with r percent interest compounding n times in t years, how many dollars we will earn after t years? The first period, the interest will be r over 100 times n, and the total money after the first period, we will get 1 times 1 plus r over 100 times n. Then it will be compounded n times t times. So this is the money after t years we will get from the bank. Next one, if we have p dollars with r percent interest compounding n times in t years, we just need to change this $1 into p times 1 plus r over 100 times n to the n times t's power. We use F to stand for the future value. This is the formula for compounding interest. Last one, p dollars with r percent interest compounding continuously in t years. Last question, p dollars with r percent interest compounding continuously in t years. Compounding continuously. As we know, $1 with 100% interest compounding continuously, we will get the money E. After a year, p dollars, so p times E. R percent will be to the r over 100 power, compounding t times. This will be the future value for compounding continuously.